Alright, so we are live, and usually I don't put my face on the chat, but this time I was like, why not? You know, why not show my face in my own live stream? So yeah, I turned on one of my lights here, and yeah. So I don't know if I don't know if having my face in the corner of this is going to kind of make it buffer a little bit more, you know. But let's just hope it doesn't slow stuff down. And let me just do a mic check real quick. All right, so I just checked and my mic works. um, so again today, VS Code is acting weird. I mean, I used VS Code like last week and it works fine with notebooks. And today, when I open notebooks with VS Code, it's acting weird. So from here, if I do code and let's say try to open this notebook, it's not turning this into a notebook. So today, VS Code is acting up again. So I'm just guessing this is a VS Code problem, you know. So I'm just guessing this is a VS Code problem. So we are going to be using JupyterLab again today, which is perfectly fine. I prefer VS Code because of autocomplete and stuff like that. But I'll go ahead and run everything, and while that's happening, and we can talk about whatever you want to talk about. Let's go ahead and run everything on this code cell. And let's see here. Some stuff is still running. Our profile report is holding us up, which is fine. And while that's happening, let's just go ahead and look at what we did last week and what we're going to be doing this week. So let's see. We want to change employment status into numbers. We want to encode employment status from string to integers. We want to change gender into integers. We want to change location code into integers. We want to change marital status into integer. So there's a whole lot of stuff we're changing into integer. We are encoding here. And then these are some visualizations we could create. Type of policy needs to be converted into integer. We need to drop this right here. We need to drop the response column. I think we've done some of this already. So these are some of the things we are going to be doing to clean the data, to keep cleaning up the data as time goes by. I'll probably work on this project till like about 9 p.m. Then I'm going to end the live stream, and then I'm going to go cook. I need to cook. So let's see. Alright, so what we did last week, where we ended last week, is that we rounded various series in our data frame, into this. And so we rounded these columns into two significant figures. I believe that's where we ended last week. Let's see. Alright, so let me see. Let's look here. So this is a visualization note that I'm making. So let's begin by changing employment status into numbers. So let's look at what employment status looks like. Let's see. Employment status. That's how it's spelled here. Let's go ahead and copy that. And let's come down here and let's do train encoded. Why are we using train encoded? Okay, so train encoded is the data frame that has our updated work. So okay, I also did the work on train. Alright, that makes sense. Okay, cool. So we are going to be using train encoded and test encoded. And if you're watching this and you're just wondering what's going on, I think I have like 3 videos on this already where like I work from the beginning up until this point. So I believe this is like the 3rd video in this series. So I already have 2 previous videos where we've done a whole lot of work on this data frame. And I'm working on this project every week, and basically I'm just spending like 3 hours a week on the project. So yeah, and every week I'm live streaming the project, so you guys will kind of see the process, you know, of taking a data science project from a data frame to deployment. And the goal is to eventually deploy this data frame, this project, using Flask or even Plotly, but I think I might go with Flask. So I want to change employment status to numbers. So let's do let's just use let's do employment status dot describe. Alright, so we have 5 unique values in employment status. Alright. By the way, if you click alternative enter, it creates a new code cell below it. So now I want to find out what values are in here. Alright, so we have employed, unemployed, medical leave, disabled, and retired. So this is like the employment status. So how do we want to encode this? How do we want to encode it? Like, does order matter in this case? So actually I need to write comments for myself so I know what I'm doing. Let me see. Let's add a code cell. Let me drag this to the top. Where did it go? You know what? I'll just delete this code cell and delete this code cell, and let's create a new one here. and let's make this into a markdown. So week 3 of project, starting with encoding employment status. What type of encoding? Does order matter in this encoding? Does order matter? So basically, like, if order matters, then we'll probably be like, oh well, if you are employed, you get you are assigned a higher value of 5. If you're unemployed, you're assigned a lower value of 4. If you're on medical leave, you get a value of 3. If you're disabled, you get a value of 2. And if you're retired, you get a value of 1. So, but I'm thinking in this case, I might do one hot encoding instead of ordinal encoding, because I feel like order doesn't really matter in this case, because just because you're unemployed shouldn't affect stuff, or retired and not. Like, so basically, does your employment status affect your insurance premium? That's a good question. Does the employment status affect your insurance premium? If we give each one a weight, then we are basically saying, if we do ordinal encoding, like up here, let me see. So in this case, order does matter, right? So doctorate is higher than master's, which is higher than bachelor's, which is higher than high school or below, right? So in this case, I'm giving a doctorate a value of 4, and then giving this doesn't even make sense. Giving a doctorate a value of 4, giving masters a value of 2. Why is this why is it giving, hold on, let me see. Bachelor's is 806. Oh, this is in the test. Let me see here. I want to make sure I didn't make any mistake. High school or below is 1891, and it should get a value of 1. Okay. So in this case, order does matter, right? But in the employment status, does order really matter? In this situation, order matters, right? Because premium is higher than extended, which is higher than basic. So the order matters. So in employment status, I can't quite decide. I don't think, like, order doesn't really matter. So I'll probably use one hot encoding. So let's see here. So there's different types of encoding, right? So let's do, so when order matters, we use ordinal encoding here. Alright, and one hot encoding is when order doesn't matter. But it's going to create more columns. Polynomial encoding, what is that? Contrast coding systems. I have no clue what that means. some contrast coding, target encoder, let's say. So features are replaced with a blend of posterior probability of the target given particular categorical value and a prior probability of the target over all of the training data. For the case of continuous target, features are replaced with a blend of the expected value of the targets given. So category encoders dot target feature, an entire integer indicating verbosity of the output, a list of columns to encode, I think I might use target encoding for this particular column. And target encoding might be the wrong type of encoding to use for the employment status column, but that's okay. As time goes by and as we experiment different things, we'll decide, okay, we want to go back and change the type of encoding that we're using for this particular column. Okay, so I'm going to use target encoding for this particular column. Or maybe I could just use one-hot encoding. I don't know. Maybe I will do both. Maybe I'll probably start off doing one-hot encoding, and then later I'll come back and try out target encoding and see if how that affects the model basically. So starts by using one-hot encoding, and then in the future come back and try out target encoding to see effects on model. Let's make this bold. Alright, so encode employment status column with encode employment status column with one-hot encoding. Experiment with target encoding later. So basically, as time goes by, I'm going to experiment with different types of encoding. Alright, so let me see. Alright. Let me say order doesn't matter in this column situation. And you might be thinking, hey, why don't I just use one type of encoding to just encode all the columns? Well, some of the columns that we have has to be encoded in a particular way because order actually matters, right? And some of the columns that I have in this situation, order doesn't matter. So one hot encoding or target encoding is probably like the better option. Alright, let's see what did you do up here. Alright, let's see. Alright, so I have my original train and then I have my original so okay, so now I'm beginning to see what I did here. So basically train encoded is where I'm doing the manipulations, and train and test is raw or manipulated data. Let me write that down so I won't keep forgetting, like what am I doing? So is data with as manipulated data frame. Cool. So now let me look at this. Alright, I just want to make sure I'm just looking up here and just making sure that I want to be consistent in the work that I'm doing. So education encoder, so this is how I created it, and then okay, I want to make sure I'm consistent in my work so I don't confuse myself later. So employment encoder is equal to ce dot one hot encoder. Alright, if we look at the documentation for one hot encoder right here, where is that? One hot encoder, verbose is 0, and then columns is equal to none. So columns is a list of columns to encode, if none. Okay, so we are giving it a list of columns, and in that case we are just giving it one column, which is employment status. Actually, alright, so this is basically what the documentation says we should do, and this is consistent with how I created all my stuff earlier. I want to make sure this what I did earlier is alright, cool. So I've defined my employment encoder. Then in this case, I basically just say so we have train encoded and test encoded is equal to all right. Let me see. Let me see. Alright, so that's consistent with how I created this code where I defined the encoder and then I did this and then encoded is equal to, let me see, how did I do this? Encoded education of fit transform train encoded using this. Okay. We have, okay. Alright, so actually I don't need here. I don't need this here. Employment encoded that fits transform train encoded, and I want to transform test encoded, and this is the columns, and I think that's all we need. Alright, now let's do train encoded employment status dot describe. Alright, let's see. Key error. Not a problem. Let's do hold on. Oh no. I screwed up in how I did this. Alright, so yeah, I screwed up. I think I needed to here. How does one hot encoder work again? Let me see. Did they give an example here? Nope, they did not give an example. Let me see here. I don't want to do this. I have to. Okay, so I'm going to rerun this. Run this entire code cell so that I'll get back to this table right here, and then I'll do the one hot encoding again. I screwed up here. So look at the result it gave us. I mean, it did the one hot encoding right, but the column names is not right. Yeah, column names is not right. Let's go ahead and run all of this again. Let's see. Yes. So let's go ahead and run everything again. And of course, this won't work because employment status column no longer exists. For a second, I forgot how one hot encoder works. Let's go ahead and run everything again and see. Let's see here if they give an example. Until the fail one hot encoder handle unknown equal to ignore. This is not. That's not a very helpful example. Let's try this again. Alright, so I don't understand why it didn't work in the first place. Or maybe employment status needs to go at the end here. I've kind of forgotten a little bit how one hot encoder works, like the syntax, and the examples are not helping either. Well, let's go ahead and run this, and if this doesn't work, it took state and put it in employment status. That's definitely not what we want. Why didn't this work the first time though? Cause we have the right syntax. It worked the first time, but it didn't give it the right names. The first time it worked, but it gave employment status 1, employment status 2. It didn't give it the right names. Let me see something real quick. Let me see. Let me think for a second here. One hot encoder columns equal to this. Okay. X. Okay, so you want to fit transform, fit to the data, then transform it. So fit transform X. So we had the right syntax though. I don't know why it didn't give it the right names. Let me see here. With coding, you're always running into problems. Let's see. Let me move this to a different location and see if maybe that will work. So see, employed should be a new column, medical leave should be a new column, unemployed should be a new column. But when we did it earlier, it said employment status 1, employment status 2, employment status 3, stuff like that. So it's like, why didn't it use the this as a column names? But no worries, we'll fix it. Alright, so we have employment encoder equal to ce.one hot encoder. This is just instantiating the one hot encoder. We don't have anything in the variable, nothing. So we're basically saying train encoded and test encoded is equal to employment encoder dot fit transform. We want to fit transform this column, and then we want to transform this column. And let's go ahead and run this. Alright. Okay, so alright, now I see. So we want to fit transform train encoded. columns equal to this. Maybe this is the syntax structure that it wants. Usually when I do one-hot encoding, I'm doing it on the whole data frame. This is kind of like the first time I've done one-hot encoding on one column. So we are saying train encoded is equal to this encoder. This is just instantiating the encoder, right? We want to fit transform train encoded, and the columns is employment status, and test encoded equal to employment encoder dot transform test encoded, and the columns is employment status. So let's go ahead now and execute this. Transform got an unexpected keywords columns. Okay. So I'm guessing you don't need to specify the columns on the second part. That's good to know. Unexpected input dimension expected 60. Why did it expect 60? Whoa. It fit transform all the columns. That is crazy. That is not what we wanted it to do. We want to just do one-hot encoding on one column. So columns equal to status employment. It didn't like obey this. So maybe this goes up here. But that's where we had it before and it didn't work though. So it's like it kind of worked, but it didn't work. It didn't work right. So this fits transform, this fits transformation on all the columns, but I don't want that though. I do not want to do one-hot encoding on all the columns. That'll be lunatic. I just want to do a one-hot encoding on a single column. Calls equal to none. So I'm guessing, I mean, putting it in a list shouldn't make a difference though. So I don't know. Let me see. Don't worry, we'll get this eventually. Yeah, it did fit. Yeah, that is crazy. Let's Google some more. So I do not want to one-hot encode the entire data frame. I just want to one-hot encode a single column. And my Wi-Fi is out. Use category names equal to false. That makes sense. That makes so much sense. That's oh my gosh. I can't believe I literally wasted the last 40 minutes of my life on this thing. This is what I was missing right here. So when I just did it without so the first time when I did this, it just said instead of doing employed, medical leave, and unemployed as the column names, it just used employment status 1, employment status 2, employment status 3 as the column names. But that's not what I want. I want to use the column names. So I figured out what the problem was. So we need to use category. We need to set this equal to true. This is false by default. So we need to set this to true. So let's see. Here. We need to set this to true. So now everything is going to come out the way we want it to be. So this is our x, and column status, use category names, yeah. Alright, everything looks good to me, so. Alright. Yeah, so employment status employed, employment status medical leave, employment status unemployed, disabled. So now everything looks right. So before, right, which it just had employment status 1, employment status 2, employment status 3. Now let's do test encoded dot head, and let's just make sure things are, yeah. So our test data set was correctly encoded, so this is good. I may rename this, but that's not a priority right now. Let me add that to my list. Actually, I can go ahead and rename it right now. Let's see. Let me see. Alright, and then let's do wait, was that the last one? We have employed, unemployed, disabled, retired, and there's one more. Medical leave. I missed that one. We want to replace it with just medical leave. Employment status employed, employment status unemployed. Okay. Alright, let's see what happened. It didn't work as expected. Let's see. It must be error in my syntax. Oh my goodness. My syntax is right. It's the dictionary. Let's see. I've done replace earlier in the game. Let's see. Why did it not work? All right, let's see. I'm out of it today. Nothing I'm doing is working. Let me see. I may have to do this manually, one by one. All right. Actually, so let me Google. How do you pandas replace? Because I don't want to do this one by one. So let's see. How to find the values that will be replaced. String rejects leaks. String exactly matching to replace will be replaced with value. Okay, so this needs to be a okay, let's see. We need to do to replace, and this can be a to find the values that we replaced, and list of string. If to replace and value are both lists, they must be the same length. So this is, for example, A, B, Y, Z. The value parameter must be none. So this is exactly what we did, and I don't understand why it's not working. So right here, right, we said we said to replace employed with employed. So I don't know why the syntax is not working. This is the syntax we're using right here. Or let me see. Employed, alright, employment status, unemployed. No. Still not working. Let's see. Well, let's do it object after. So does the replacement happen in place though? Let's say in place is false. Zero to 5. I'm thinking of this the wrong way. I'm thinking of this the wrong way. Oh my gosh. Like I said, I'm out of it today. I'm out of it today. I'm thinking of this the wrong way. I'm trying to change the column names. Oh gosh, I can't believe myself. Now I know what's happening. Um, this replace function is for replacing values in the data frame. Okay, and what I'm trying to do is change the column names. I'm trying to change the column names, and but this pandas replace function is for replacing the values. It's not for changing the column names. I'm I'm out of it for real. So probably the easiest way to do this is to do I'm out of it today. Oh man. This is usually how I change column names. Let's go ahead and run this. Oh no, I did this backwards. So we're basically saying employed is equal to this. Let's run this now and let's do it's created a new column called employed. Let's see, change column names, and I want to do all of it. Change pandas, change column name. Oh, dot rename is the function. Let's see, data frame dot rename self mapper. Alright, so mapper dictionary like of function transformation to apply to that axis values. Use either mapper and axis to specify the axis to target with mapper, or index and columns. Alright, let's see. Index, alternative to specifying axis. Mapper, alternative to specifying axis. Columns equal to mapper. Alright. Data frame dot rename supports two column conventions. Index equal to index mapper. Columns equal to columns mapper. Columns equal to A, B, B. Alright. Let me see. I want to see the syntax here. Okay, so I figured out how to do it. So we are supposed to be using dot rename here, and then it's supposed to be mapper equal to, right? So no, columns. We just say columns. If we use mapper, then we have to specify the axis. But in this case, we're just doing columns equal to a dictionary containing what we want it to be. Alright, and let's see. Index equal to 0. Alright, let's go ahead and execute this. And now let's do this. Look, it worked. So now let me do dot drop. Oh, Shiba made timbers. Um, if I do that, it's going to drop this column and this column that I created at the end. What if I just drop the last column? How about I use indexing to drop the last column? So let's see. Hold on. Alright, so let's see. Index. I wonder, could I just do -1? Let me see. I was thinking maybe I could just do columns equal to -1 or something like that. Single label or list like index or column labels to drop. Okay, labels, index or column labels to drop. So I'm just going to do index, which is -1. So it's called labels equal to -1. Let's run that and see. Now single label or list like let's just use drop duplicates. Determines which duplicates, if any, to keep. So the default is to keep the first duplicate and then drop everything else. So drop duplicate except for the first occurrence. And keep union. So first is okay, so this works perfect. Drop duplicates. So this is perfect actually. So here we want to use drop duplicate. And it's just going to automatically drop so employed here and employed here are duplicate columns, so it's going to drop them. and hopefully to just keep this employed column and leave this one out. We'll see. So we still have employed here, and we still have employed here, so it didn't work. So why did it not work? Let me see. I'm just going to do this manually instead of wasting time on this. Okay, so you are saying this column is equal to this column. Let's go ahead and run this. Yeah, we have two employed column, and I don't understand why it's not dropping the second one. So yeah, we can't even do this because we have two employed columns. So when I say drop this, so it's like yeah, I messed up real bad. So let me call this employed 1, because if I do just dot drop employed, what it's going to do is just going to drop both of those columns, and I don't want to drop both of the columns. I just want to drop one of the columns. So let's just do train encoded. Let me do change both of those columns to employed 1. Let me see. All right. Alright, I need to find a way to just drop one of them. Column label or sequence of labels. Alright, so let me try this again. Let me try this dot drop duplicate. Actually, Let me try. I really want this for this to work. It should be able to. I don't know why it's not working. Why it's not able to drop the duplicate. Uh-oh, what happened? Yikes. I messed up. I messed up everything. You know what? I can start over. I can start over. Yikes. It did not drop the duplicates. So I don't know what's going on with this drop duplicate function. But let's go ahead and restart my kernel. And yeah, let's just go ahead and start over. And we just patiently wait. So basically, when I restart my kernel, it's going to remove everything in memory, and then yeah, all the mistakes I made at the end will be gone. Okay, everything is back to how it's supposed to be. I just restart my kernel and erase everything. I mean, I should have done this at the beginning, but I wanted to try new things. That's the whole point of working on projects. You know, you get to try new things and experiment and see what works and what doesn't work. So let me go ahead and push this to GitHub. So let me see. Alright. I'm up to date with Origin Master. Alright, let's see. The next thing on our list was changing gender into numbers. That's just binary. But I don't want to give any gender more weight. If I do, let's say, male 1, right? So I don't want to give any gender more weight than it needs to be. So let's say oh, actually I need to do this too. I need to repeat this process for my test. So test in okay, I want this to be test. Alright. And now let's see encode gender to be numerical. Now let's do train gender, is that the column name? column name is gender dot value counts. So we have male and female, so we only have two values for gender. So if I don't want to give, like, let's say male 1 and then female 2, or male 0, female 1, so I'm going to encode I'm going to also do one hot encoding for gender to avoid giving weight to anyone more gender, because if I give 1 to male and 2 to female, then I'm kind of building bias into the model, right? Because the number 2 is higher than the number 1, so I'm kind of building bias into the model, and I don't want that. I don't want to build bias into my model. So I'm going to use one hot encoding for gender. So I'm basically going to do what I did up here. I call this gender alright, let's see, gender alright, that's right. Now let's do train encoded dot head. Now let's see, gender male, gender female. Sounds good to me, but I want to change that. So let's just use this line of code that we used earlier. Gender column names. And train and test dataset. Alright, so train encoded, and then we want to rename gender M to just male, and then we want to rename gender F to just female. And then I want to copy all of this, and let's change this to test, and then test. So we want to rename gender male this. Alright, let's go ahead and execute this, and let me see. Male and female, excellent, exactly what we want. Alright, so let's push to GitHub, get add, get commit, message, I am encoded gender to numbers and changed column names. You know what they say about data scientists spending You know what they say about data scientists spending 80% of their time cleaning the data and then 20% of their time on the model? That's so true. Like I spent the last 3 weeks just working on cleaning this data, and I still have a lot of data cleaning to do, a whole lot of data visualization to do, before I get it to the point where I'm like, okay, I feel confident putting this through a model, right? But right now I'm just like kind of just cleaning up the data, and then after I'm done cleaning the data, I will create visualizations to sort of visualize what's going on, with this data set, kind of try to understand it a little bit better. And then after I've created like more understanding of the data, then I'm going to put this through a model. So the model is kind of like the last piece of the puzzle. And then after I have my model, I will I'll then build a Flask app to put this online. That's gonna be fun. It's gonna be a whole lot of fun. So let's go up here and see what else we need to do. So we've done this. Change location code into integer. Location code and marital status, let's change that into integer. Okay. Location code. Alright, location code. So let's see. Let's do dot describe. So only 3 unique values. That's good. That's candidate for one hot encoding. But let's look at it a little bit more. Let's do not one hot encoding, but let's do value count. So we have suburban, okay, rural, urban, okay, and in this situation, I'm not going to assign any particular order to this. I don't want to give any weight. To this. So if I assign 1 to suburban, 2 to rural, 3 to urban, then when I run this through the algorithm is going to think urban is more valuable than suburban, just because urban has a value of 2 and suburban has a value of 1, has a value of 0 or something like that. So I'm going to use one hot encoding in this case too. Yeah, so this is a one hot encoding problem. So encode location code column with one hot encoding. Order doesn't matter in this case. Oh, Control Z. What did I do? Location code, and this is location encoder. Location encoder. Location encoder. Alright. That looks good to me. And then I do train encoded dot head. Location, okay. The encoding works. Let me change the column names. And of course, like I keep saying, eventually I'm going to refactor this notebook and take all of this data cleaning process and put them in a function, so I can just call that function and clean the data with just a single function. Like, I'm seriously looking forward to that. Like, I'm super excited. um is it called Bemis? Says 3 weeks. Yeah, 3 weeks, but it's not like my lambda's journey is going very well. I switched from full-time to part-time because I just want to take more time to kind of learn the stuff and absorb it. I just finished working as a team lead at Lambda. So instead of finishing this year, I'm going to be finishing next year. But I really don't mind. I can start looking for a job before then. I can work on personal projects like this and stuff like that. Yeah, and but I mean 3 weeks, but it's not. I've not been working on it every single day for 3 weeks. Like, I've been working on it for like 3 hours per week. So I think about 4 weeks ago, I live streamed this project. I worked on it for about 3 hours, and last week I worked on it for about 3 hours, and this week I'm working on it until 9 p.m. So only about 3 hours. So it's not as if I'm like working on it a whole lot every single day. Like, no, like no, I'm just working on it 3 hours in a per week. I'm not like spending a whole lot of time on it. If I spend every day on this project, then I can probably finish it up in 2 to 3 weeks. And that means data cleaning, visualizations, data exploration, putting it through the model, experimenting with different models, building a Flask app for it, and everything. They might probably take me up to like, let's say, 3 to 4 weeks if I dedicate time to it. But since I'm only doing it a few hours a week, that's why it's taking me this long. But yeah. Oh, thank you. I create those those videos because I remember, like, when I first started Lambda, I would search for stuff on the internet, and I'd be so frustrated and upset that I couldn't find like a simple step-by-step guide on how to do this one particular little thing. And it made me so mad. I was like, I'm going to create videos. I'm going to create simple videos for the data science community, so that in the future, when other people are starting out just like me. Yes, so basically, when other people are starting out just like me, they will have videos to go to. But yeah, the Flask is to show my results to others on the web. Yes, so basically I could put it in Plotly Dash, but my Flask skills are not very good, so I kind of want to use this project to really learn Flask and learn a little bit of web development and learn how to put stuff on the web. And once I learn Flask, it will be easier to, like, let's say, work with Plotly Dash if I wanted to. But yeah, Flask is instead of the models, just living on my computer like this, on my notebook, what will happen is I'll give somebody the URL, and the person can click on the URL and play with the model and change different things and see results, right on the web. So yeah, Flask is just for putting it on the web. Yeah. And if you have any more questions, just keep it coming. And let's go ahead and change the column names here. So we want to change these column names to urban. And let's change that to just rural. Awesome. Yeah. And let's change this. Yeah, it's really cool to create a project, and instead of the project just living on your notebook, the project will be available for other people to see. That's That's the dream, right? I mean, like, if you go to my website, well, the internet is failing me again. Let's see. Is better than Jupyter Notebook. Okay, so if we go here to Anaconda and launch Jupyter Notebook, you have to go to, you have to like click back to a different window to get access to your folders and stuff. But with Jupyter Lab, right, I have my folders out here and everything just looks a whole lot better. So I just prefer Jupyter Lab because it looks better, it runs a little bit better, and if you're working with virtual environments, you get to see which virtual environments you're working with and all that stuff. So Jupyter Lab is like VS Code Notebook combined with Jupyter Notebook. I don't know if you've used VS Code. I don't know if you've used Notebook inside VS Code. But sometimes Notebook inside VS Code doesn't work, but when it works, it's really, really good. So yeah, yes, please do it. I keep telling everybody about Jupyter Lab. I think Jupyter Lab is the bomb. Let me go ahead and close this connection here. So yeah, actually, if you go to, I don't know why that's not loading properly. I'm going to find out. So if you go to my portfolio, right, I have my portfolios here. I need to find out why my images is not working. So for example, for this one, for this project, so this is a project that I did. So I have the project here and I wrote a blog about it, but there's no website in a such where you can like kind of play with this project. And even this project that I worked on, if stuff my website's a little bit slow and I need to figure out a way to make it a little bit faster. I'm working on it, I promise. I think is this, okay, there it is. So like this one, I don't have a website. I don't like this project. Is just really cool, predicting life expectancy. I'm thinking of taking this project and putting it online, so you can kind of play with it, and instead of it just being a blog post, so that's the whole point of Flask or Plotly Dash, putting your work online. No, that's just a blog post. No, my website is done in WordPress. So yeah, I'm using WordPress for my website. I started this website before I started learning how to code, and I've been using WordPress for a long time, so I just use WordPress. So yeah, the website is done in WordPress. And let's keep going here. Yeah, WordPress and Elementor. So I use something called Elementor in WordPress. So if you go to, so Elementor, this allows you to build custom websites inside WordPress. That's how I'm able to build my website out. Yeah, so I use Elementor inside WordPress to build out my website. It's pretty cool. I mean, my website is due for a revamp, but it's not a priority. so Suburban. Let me go ahead and copy all of this. Let's see. Yeah, well, that's good. I'm happy you're learning stuff. Earlier, I had a little bit of problem with one hot encoding, so, but I got it figured out. So, let's see. That's N right there. I'm happy you are learning stuff. That's why we are doing this. You know, like before I started learning how to code and data science, right? I always wish there was somebody like live streaming data science project, so I could kind of get an idea of how to work a data science project, and if I was interested in data science and stuff. But I'm interested in data science now, but I would have liked to know, what it was like to work on a data science project before I signed up for a data science bootcamp. So yeah. Anyway, let's see. So we've changed location into integer. The last thing that we are going to change into integer here is marital status and sales channel and state. Let me see. I think I might do target encoding for state because I'm not about to encode that manually. But look at sales channel and marital status. So let me make a quick note here. So change to integer these columns. Well, thank you. Yeah, I'm trying to keep creating content and providing value, marital status, let's see, sales channel, state, vehicle size, and sales channel, marital status, type of policy. So basically I'm doing all this data cleaning so that I'll be able to run this through my model, because most models does not understand text. Like your stuff that goes through the model has to be integers, not strings. So we have to change things to integer, and it also makes visualizing everything easier if everything is integer. So state, sales channel, vehicle class. I'm so excited. Like when I finish all of this, I'm going to create a function that will do all of this at once. But when I first start writing code, or when I first start working on a new project, I like to do this encodings manually and kind of start building intuition for the data set, before I start creating a massive function. And even if you create a massive function, right, you don't know what the function, like you don't know what to put in the function, what you need to be doing and stuff. Like up here I had to use ordinal encoding, but down here I had to use like one hot encoding, and in future I'll probably use target encoding, stuff like that. So it's like you don't know what type of encoding you're going to need for the different columns. So vehicle size needs to be encoded, vehicle class, I got that. Change sales channel to integer, state. Alright, so those are the only encodings left. So let me go ahead and copy this. So I can have it down here, so I don't have to keep scrolling back and forth. Alright, so marital status. So let's look at here. So this is method status, policy type, policy. Okay. Alright, so all of this is needs to be encoded. Vehicle class, vehicle size. So in this situation, vehicle size kind of matters, right? Because large will probably give large a number 3, mid-size 1. So these are the encodings I'm going to do. I'll probably do it all at once. So let me say columns to encode is equal to this needs to be in a list. Instead of doing it individually like this, I'm going to try to do all the columns at once, because all of this looks like a one-hot encoding problem. So marital status, right? I think it's just space. Even before I do this, I want to do the reason why I'm doing this is to make sure I know what's in there. So if we look at marital status, we have married, single, and divorced. We only have 3. That's good. And then we are looking at policy type. Let's do this here. Oops, what did I do? Just policy type. All right. So in this case we also only have 3, which is good. And only having 3 will allow is good, because if this was like 200, then one-hot encoding is not ideal for it, because it's going to create too many columns. With one-hot encoding, it creates a new column for each variable. So this used to be urban. Oh well, you don't have to be really good at math to do data science. You just have to be willing to learn math. Like there are some aspects of data science that requires a good amount of math, and you need to learn like basics of linear algebra and statistics and things like that, right? And let me do something real quick. So if I do something like train encoded dot describe, right, it gives you a whole bunch of numbers. It gives you, the count, the mean, the standard deviation, the minimum, 25 percentile, 50 percentile, and other stuff. It gives you all these numbers. For example, you kind of need to know what they mean, and how to use it and when to use it and stuff like that. So you don't have to be like a math wizard to be a data scientist. You just have to be willing to learn the basics of linear algebra and statistics, and then depending on which area of data science you are going into, it might require you to learn more specific math. So if you're going into computer vision, right, or deep learning, then knowing math and the theoretical knowledge behind the code you're writing, makes a whole lot of sense. But there are some, if you're just doing data analysis just analyzing data, maybe creating visualization, then maybe extensive math is not needed. So don't let math scare you away from data science. Like, don't do that. Like, because the math, it's good to have intuition of the math, but you won't be dealing with a whole lot of math on a day-to-day basis. It just depends on which area of data science you decide to specialize in. And personally, I still haven't decided which area of data science I want to specialize in. Like, I like data analysis and visualization. I really like Tableau, the software, and I'm really good at it. But still, I haven't decided which area of data science I want to specialize in. So yeah, don't let the math scare you away from data science. Alright, so I don't need this information. I'll go ahead and cut it. Yeah, so policy type, let's say columns. Let's see, what are the columns? So policy type, policy. Let's look at policy. All right, so with policy we have I don't know. All right, so let's do the describe here. So we have 9 unique values. All right, and I feel like order matters in this case, right? So L1 will probably be like level 1, and then level 2, level 3. So personal L1, so we could give personal L1 a value of 3, and then I feel like order will matter in this case. You know, which policy you get would matter. Yeah, I feel like the policy that you get will affect your car insurance premium. So we could do we could give this from a value of 1. You know, we could do a value of 2, a value of 3, but then a value of 4. But then in that case, we are comparing corporate to personal. Let's just do one hot encoding, because once you start giving order to stuff, you could introduce bias into it. So let's just do one hot encoding with policy. And let me make a note of that. So it's good to write comments as you're writing your code, so you won't forget. Policy could have an order, but that order could also introduce bias. So one hot encoding was used for policy. Alright, so we have policy. Let's see, what other column do we have here? Sales channel. Let's see what sales channel looks like. Is that how you spell sales channel? Is that how they spelled it? That is how they spelled it. So we only have 4 values here, and in this case, let's just do sales channel. And let's see, vehicle class, vehicle size. I've been coding for at least 3 years now, like on and off. Like I started off with HTML and CSS. I really liked HTML and CSS, and then I went on to, I tried JavaScript, and I was like, man, JavaScript is too tough. And then I tried Python. I really liked Python, so I stuck with Python. Then I started looking for careers that has to do with Python. I came across data science. I was like, this looks interesting. So then I got into data science. So I've been doing data science work for about a year now. I've been working in data science for about a year now, but I've been coding for a total of about 3 years. So it's been a fun journey. Yeah, it's been really fun. So yeah, JavaScript is really confusing. It's like, especially if it's like if JavaScript is the first object-oriented programming language that you learn, it's really confusing. But if you learn something like Python first and then go back to JavaScript, JavaScript makes a little bit more sense, but it's still very confusing. JavaScript is very confusing, especially compared to Python. So yeah. So we have vehicle class and vehicle size. Let's see. So vehicle class has about 6 items here. We'll also encode it. And then we have vehicle size. Alright, so in this situation, order actually matters. So small will probably get a value of 1, mid-size probably get a value of 2, and large will be a value of 3. So I'm not going to add it. So this is columns to encode. This is one hot encoding columns, and this is going to be ordinal encoding columns. I'm just going to call this vehicle size encoding. I'm just going to call this vehicle size. Alright, let me go ahead and run this, and now let's start the encoding. Let's start first by doing ordinal encoding here. And last week I did ordinal encoding, so let me go ahead and find that. I believe I used code like this to do ordinal encoding. Alright, so this is my this is going to be my dictionary for the ordinal encoding. Like if you want to learn more about encoding, you just go to Google sklearn encoding or something like that, I believe. But this is the website. Oh, my Wi-Fi. So let's do. No, this is not what I'm looking for. I'm looking for category encoders. That's what you should be looking for. So if you go to this website, which is this website, you can look up wherever it says small. I wanted to give it a value of 1. Whatever it says mid-size, right? Mid-size, med-size, mid-size, med-size. How did you spell it? and then large is going to get a value of 2. I mean a value of 3, and I don't need 4 in this case. Alright, so this is the dictionary of like how I'm going to do the mapping. Wherever there's small, get a value of 1. Wherever it says mid-size, give it a value of 2. Wherever it's large, give it a value of 3. Alright, do I have this? And I have this. And the column to use is vehicle size. And education encoder equal to CE. Okay, I want to call this vehicle. And on the columns is going to be vehicle size. And the mapping to use is vehicle dictionary. Using ordinal encoding because large, medium, small indicates a natural order. Alright, and then so train encoded this right here is not necessary for this particular one. So I'm saying train encoded is equal to vehicle encoder. I want to first transform train encoded, and then test encoded is equal to vehicle encoder, and I want to transform train encoded. Alright. That looks good to me. Everything, I've defined the dictionary to use, you know how to map it, and then I've instantiated the ordinal encoder using telling it the column, and then also telling it the mapping to use. And now I'm fit transforming this encoder on this data frame and then transforming it on this data frame. Makes a whole lot of sense to me. Alright, let's go ahead and run this. If you run into errors, we just fix it and see. Alright, let's go ahead and run this. And now let's do train encoded.head. And let's go to vehicle size. See, vehicle size has been changed into integers 3, 2, 3, 2, 2. And if we go out here, it says large, mid-size, large, mid-size, mid-size. Excellent. And if we so that's good. Now let's do let's say encode. Like if you have any question, you can ask question in the comments too. Like if you I know, like if you don't know data science, this might seem like what the heck is she doing, but if you have questions or if you have any suggestion of how I could do something better or faster, let me know in the comments. I'm all for it. Encode the remainder of columns using one hot encoder. So these are the columns I do want to encode. And let's copy this code I wrote out here. I'm a big fan of copying your own code. Like there's absolutely no reason why you should rewrite your code 10 times when you can just copy and paste it. So encode columns above in this columns situation. Alright, so I just got it columns encode equal to ce.1hot encoder. CE stands for categorical encoders. ce.1hot encoder columns is equal to columns to encode. So basically I'm saying that the columns is equal to these columns, right? I want to use the categorical names, and train encoded equal to columns encoder.fit transform, and then test encoded is equal to columns dot transform. Yes, actually yes. So one hot so yeah, data scientists do use one hot encoder in production work. So if you go to like the things I'm doing right now is what data scientists do in production, but if you go here, you see different types of encodings you could use for categorical variables, right? And depending on the problem you are trying to solve, depending on your data frame, you might decide to choose, depending on the problem you are trying to solve, depending on your data frame, and depending on different things, and also based on your experience, you get to choose the right encoding for the job you're working with. But yeah, like the scikit-learn library is what data scientists used. Pandas, NumPy, that's what data scientists use in production. I mean, if they didn't use it in production, why would I use it? But yeah, I don't know why it's called one hot encoding. Actually, one hot encoding is like for dummy encoding, but I don't know. I didn't name it one hot encoding, okay? Alright, so these are the columns I want to encode. Encode, use cat names, true. And yeah, let's go and execute this. And now let's do train encoded dot head. We got a problem. Encoded. There we go. So now let's see if things worked as expected. So marital status divorced, marital status married has been changed as marital status has been changed as expected. And then policy type has all been changed. I'm going to drop this column. Alright, so our one hot encoding worked as expected. So it's almost 9 p.m. I'm going to do a couple of things, and then I'm going to call it a night or a week. And then when I come back next week, when I live stream again next week, I'm going to focus next week on creating visualizations. So now let's do a couple of things. So let's drop let's see, let me copy this whole thing. So paste cells below. Yes, I usually live stream on Mondays, but this week I ran into a little problem on Monday and I couldn't live stream. So I'm going to be live streaming on Mondays. I used to live stream at night on Mondays, but I'm thinking of moving it either to Thursday evenings like this permanently, or Monday morning. But usually on Monday mornings people are at work, right? So I'll probably stick to Thursday evenings because I know for the most part I'm available on Thursday evenings. So Yeah, I'll probably say Thursday evening I'm going to be live streaming. And if like the day and time changes, I'll probably say Thursdays around 5-6 p.m. And if the day or time changes, then I'll let you guys know. So yeah. So we've done majority of this already. So this is the visualizations that I'm going to create. We've done this. So now I'm going to drop renew offer and response column because we don't know what response means. Yeah, so we are going to also drop renew offer because we don't know what offer 1, offer 2, offer 3 means in this data set. Like, so their renew offer was offer 1. Okay, what type of policy is offer 1? We don't know that. So yeah, so we are going to be dropping this right now. And we've already done this here. Oh, states. Does the state you live in affect your policy? Maybe yes, maybe no. I'm going to do ordinal encoding for states, but I'm not going to give it any so if you go to my GitHub, actually I'm going to paste this in the comment section right now. So if you go to, let me see, here, let me see. Yeah, I thought I had this in the comment section, so let me see here. So I just added it to the comment section of this video. You can find the project notebook there. Or you can just go to evidencen.com and then go to insurance premium prediction. And then you can click on fork and then you can get your own copy of it. So yeah. So I'm going to change states to integers, and then we've already done this stuff. So we've already done this. So basically, let me create a new. So let me go ahead and copy this. You're welcome. You're welcome. Let me change this to markdown. And let me just copy this. I don't need this here. And now let's see. So I'm going to encode states real quick, and then I'm going to drop these columns that I want to drop. So let's see, target column. All right. Does the state you live in, affect the price of your insurance policy? Maybe yes, maybe no. We don't know yet. So in this case, I'm going to encode states using ordinal encoding without specifying order. So let me Google something real quick. Best way to encode state. Encode state in a data frame. Label encodings. Let me see. This is one hot encoding right here. I just use ordinal encoding because I was thinking like maybe is there like a better encoder. But after I build the model, I can come back and experiment with different encodings for the state or for the other columns, trying to find out okay which encoding is better for this model that I built. But as of right now, just start with ordinal encoding. So I've already done some ordinal encoding up here, and in this case I'm not going to be providing let's say come back and experiment with different encodings later. So I'm going to call this, so I don't need this, I don't want to specify a dictionary, I want the numbers to be random. So I'm going to call this state encoder equal to state. I believe that's how it's spelled, just state. Alright, and then that's not necessary. State. Alright. Now let's do train encoded.head. So now, okay, so state has been encoded and we didn't give it any order. It just the order was picked randomly. So yeah, hopefully this random ordering doesn't introduce bias into the model. But I couldn't do one hot encoding with this one because there are too many unique values. So if I do train state dot describe, oh, there's only 5 unique states. Okay, that's my mistake. That's really my mistake. I thought there were like gonna be like 50 states, but there were only 5 states in this situation. So if I do one hot encoding in this situation, I'm only going to end up with 5 extra columns as opposed to ending up with like 50 extra columns, each column for each state. So yeah, I'm going to re-encode this. I'm going to change this to one hot encoder, and I want this line of code here. Okay, so this is why you always want to do dot describe and dot value count, and explore the data before you make changes to it. So I did this without doing dot describe first and without knowing what was inside my state column, and I did an encoding that wasn't necessary. So let me remove this. So this is why it's always good to do this step. So now I'm going to one hot encode state. This is right. And in order for me to in order for me to accomplish this, I'm going to have to remove train encoded from memory and just use, yeah. So now let's do that. So it's going to take a while to run everything again. While that's happening, I'll go ahead and do get add, get commit. My message is going to be encoded all columns. Get status. So I'm 2 comments ahead of branch, which is great. By the way, I don't know if you've noticed this, but this sign right here means that Jupyter Lab is working. And I've also this sign here. Let's see. Take out some more. It's working with. Okay. Alright, so everything is done running. If we go back down here, everything should be exactly as we. Okay. Expected 50. Let's see. State encoder.transform. Oh. But did I use train encoded the whole time? Oh, okay, I used test encoded. I was like, did I screw up? Was I screwing up the whole time and I didn't know? Oh no, this is supposed to be test. How did I screw up the whole time and I didn't know? And why didn't it throw an error here? Oh, that's a bummer. It's fine. It's good that I caught it now. That one is good. I screwed up one time, but it's fine. Yeah. Okay, let's run this again. Key error state. Key error state. What do you mean key error state? You know what? I'm just going to delete my kernel and run this all over again. Before I do that, let me just verify that I don't have any more errors here. I'm pretty much done for today. Like, I just need to change a couple of column names and then drop a few columns, and then I'm done. So for today, and then next week I'll just focus on, actually next week I'm going to focus on refactoring the code. So refactoring, I see I have like the same things written over and over again in multiple places. So refactoring the code is basically taking all of this data wrangling process and putting it in a function. So I'm going to do that next week, and then if I still have time, I'm going to start working on the visualization. So actually I can, let's this this right here is what's taking so long, but I don't need this information. So let's go ahead and do this, and everything should run really fast. All right, see, that was really fast because we didn't have that profile report right there. All right, so state Arizona, state Oregon, state California, state Nevada, state Washington. Cool, everything now works as expected. Let me go ahead and drop the columns. So drop response and what other column are we dropping? Response and response and renew offer. Okay. I need to find renew offer so I can see how it's spelled. Renew offer. Renew offer type and alright, so basically in this case I'm going to do train encoded is equal to train encoded dot drop columns equal to response and then renew offer type. Renew offer type, right? And it's called response at the beginning. Yeah. And let's do this for the test too. All right, let's see here. Response column is gone and renew offer type is gone. Excellent. So change column names to something easier to pronounce. All right, so all right, this is going to be a long dictionary, so let's start from the beginning. I want to change state Arizona. Like, just changing the column names will just make it easier to type it in the future. Like in the future when I'm working with this, it makes it a whole lot easier to type it out. Arizona. I mean, right now it might seem like a tedious process to go through and rename everything, but if you don't do this right now, it will be a pain in the butt trying to type out these column names over and over and over again. Washington, and then I want to change what don't let's just say lifetime value. I didn't need to change this one, but still this is just a matter of personal preference. But yeah, this is pretty much the last thing I'm going to do today, and then I'll call it a day. And then I'm going to go cook. I have to feed myself, so I have to cook, and I really don't eat out a lot. Like, just eating out is not my thing. So I have to cook. And after cooking, I'll probably just go to bed or watch Netflix. I haven't decided yet. Monthly premium auto. I'll just call this premium. I'll call this I want to call this last claim. Well, month since policy inception. I'll leave that one as it is. That's descriptive of enough. Actually, I'm not going to change month since last claim. I'm going to leave this one as it is. When you say premium, that's kind of implied how much money you pay every month. I'll just focus on changing these ones that look absolutely ridiculous. That was my original intention anyways. This is personal auto. corporate auto. Actually, I'm going to leave these ones premium. I'm going to leave this because this is descriptive enough. I don't want to remove so much information from the column names that I forget what I'm doing. I don't want to get to the point where I'm like, what does this column mean? What does this column mean? So I want to make sure I leave this information. So yeah, the reason why I'm changing these column names because they are kind of redundant, you know. And policy type, corporate auto, that's a little bit difficult to remember and type. So I'm changing those ones. Policy type, personal, special, auto. And corporate L3. Alright, and then policy. So this is already confusing. Policy corporate L2. Okay, L1. And then L2 and L1 for special. Okay. So this is already confusing. L2, L2, right? L1, L1. Personal. L2, L2. L1 and L1. And then this is special. Now let's see. The policy special L2. It has L2, L1, and L3. Okay. L2. I know this seems like unnecessary tedious work, but it's absolutely necessary to clarify things. L3. You know, the things like in the media they make their signs sound so sexy, but this right here, typing out stuff like this, that's what data science is. It's like a lot of typing, and it's not as sexy as they portray it in the media, which is crazy. Alright, so now I want to change sales channel call center. We have call center agent branch web. Yeah, this is a lot of work, but that's our job, right? Sales channel agent. Agent, let's see. Yeah, this is a lot of work, but it's the preliminary work necessary for everything to. This is just preliminary work to make my life easier as time goes by. Branch. And then, so I want to change total claim amount is fine. I'll just change it to claim amount. It's fine. I just want to focus on these ones that look absolutely ridiculous. Vehicle class 2-door. So in the previous week, I changed this into dates. I remember this one. Vehicle class 2-door. I just want it to be called 2-door. And then vehicle class SUV. Is just SUV. I'm sure there's typos in this somewhere, and this is probably going to throw an error, which is fine. And we'll just fix it if it throws an error, right? Vehicle class sports car. And then vehicle class 4-door car. Okay. We'll call this 4-door. And we're almost done here. So there's luxury XUV, luxury car. Okay. We'll just call this luxury SUV, and then luxury car. No, yeah, luxury car here. And I believe this is the last one of the looking ridiculous column names. We'll just call this luxury car. Alright, let's go ahead and run this, and if it throws an error, any errors, we'll just fix it. Right, that's what we do. We fix errors. And let me do train tests encoded. right. Now let's do train encoded dot head. It did not work. Excellent. All right, so what am I missing? Why didn't it work? Let me scroll up a little bit to see where I did the rename. I have to specify columns equal to. You've got to be kidding me. Alright, so columns equal to. This is why it didn't work. Columns equal to. Now it works. There we go. So everything looks right. California. I spelled this. I can't spell California. I knew I had a typo. I spelled California wrong. Can you believe it? California. Well, how do you spell California? I just forgot. Oh, no, I did not. I did spell it wrong. So it's NIA. And let's say NIA. There's anything else? Employed, medical leave, unemployed. Everything else looks good to me. The column names look a lot better than what we had up here. You know. So oh, it's fine. So anyway, that's it. If you have like any question, just let me know, and I'm going to go ahead and commit this. So real quick here. So next week, refactor all the data wrangling code. Refactor all the data wrangling code and put everything in a giant function, because that's exactly what it's going to be. It's going to be a giant function. And then if there is still time, work on data visualization, or yeah, just work on data visualization and exploration. So everything is saved, and then let me go ahead and git add everything, git commit. My message is going to be done with data wrangling and column renaming. Get status. So I am ahead of branch by 3 comments, so let me go ahead and put everything online. Get push origin master. Alright, let's get status again. I'm up to date, and just because I'm paranoid, let me refresh this. And 30 seconds ago, everything is done here. Yep, done with wrangling data and column renaming. Yep. So everything that I just did is on here. Looks like somebody just joined us just when we are finishing. You can click from the beginning and watch it, and just skip the first what do I say? Skip the first 45 minutes. It was just me trying to figure stuff out. I'm just gonna scroll the way to the end and make sure I have everything that I need. Yep, that's it right there. Excellent. So I'm pretty much done. If you have any questions, just let me know. If you don't have any question, I'm going to end today's live stream. It has been fun. It has been a whole lot of fun. So, file shutdown. And just if you have any question, just leave comments in the comment section below, and I respond to all my comments. I really do. So, yeah. Thank you for watching, and bye.